environment available for searching, using, deploying of new e-mobility services. In addition, all of these services are homegrown and have its own information model. So there is a lack of a common information model for these services. So it's easy to be used for other e-mobility stakeholders to generate new services. Okay, in addition, as said, it's really hard to find these services. Also, the services and the stakeholders are not so visible across Europe. So it's really difficult for companies to bring their services into the market, and for companies who want to use the services, and of course for both of them to generate new applications and make profits, signing contracts. So, and how do we address these issues? This is the NEMO solution approach. The NEMO we differentiate from today's centralized approach is hosted by a single provider, like a store, what application store, as you know, in the market. The NEMO project provides a distributed and blockchain-based environment to create services, to deliver services, and execute them, and provide them to all ecosystem partners connected to the NEMO. Where all participants, of course, based on blockchain, can share the same data about the NEMO partners, services, and contracts. So it's not all centralized, it's across the blockchain network. Okay, on these pictures you see the blockchain business network with the ledger in the center here. Let's see my mouse. Surrounded by the partners using and providing the services. The interaction between the services, as said, is based on a common agreed information model, our NEMO SIM model. And this IT environment enables seamless integration of the data, of course, and the services used by the developers and the business users. The NEMO business network provides, of course, APIs and browser-based application for the users to interact with the system. For example, for partner management, here for service repository, a repository which holds all the services with information about the service, semantic model. Niels from TUB will give you more detailed insight later in the session. And of course, contract management, where you can bring in your contracts with all the business relevant information and SLAs and other non-functional information, as well as with some monetization. So surrounding this, you see the NEMO partner systems, as Christina already mentioned some of them. These are the electromobility providers. Here, the DSOs, the distribution system operator DSOs, the third-party service providers like MEC providers on a B2B level, and electromobility providers. So these are, for example, automotive companies that can provide the services on a B2B level, as well as to the end consumers on a B2C level. Okay. Now drilling a little bit deeper, how this look like in a NEMO technical IT environment. As mentioned, this is based on blockchain. So here I put a small blockchain picture in. If you are not familiar with blockchain, please have a look and make you familiar a little bit with blockchain. So on this picture, you see one instance of the NEMO IT environment here. A so-called NEMO node, which is hosted and operated in a data center or in the cloud of a NEMO business partner. So we encourage every NEMO partner later to, of course, host his own node and be part of the NEMO blockchain network. On the left, you see the actors starting from top. For example, electromobility user interacting with the NEMO mobility provider application. Where's my mouse? Here. This can be, of course, a car, an in-car application, or it can be mobile or any other service provider's application up to charging station. So this is the end user use case, but of course we first need to develop such applications. So where you see on the left, you see the service developer here. No, where's my mouse? Here. The service developer is using and interacting with the service, so-called service creation domain, where he can create and register new services, find services in a NeMo hypernetwork, and generate as well applications or high-level services. As said, that all tasks the developer is doing will be explained in the next session or webinar by Johannes from TUB in more detail, and on how to build and deploy such new services, providing additional features using the existing services from NeMo partners. On the left, you also see the business user interacting with the system. For example, adding contracts or contracting services from other service provider. Okay. As said, the NeMo is a network. So this is an example how two nodes at two data centers from two partners are hosted. So data center A is, for example, the center from a partner where he hosts one of the nodes, and data center B is a node from other in the NeMo network. And of course, if the data center with the services and contracts are replicated, you see, are replicated here, are replicated between a node as well as the blockchain consensus mechanism. If a service or an application from partner A hosted in data center A is using a service in data center B, then of course there will be a remote invocation. The service can be found and linked during build time. So you can be statically linked. That's what Johannes is showing in a minute, or it can also be dynamically found and invoked during runtime. So there is also the possibility to dynamically find a new service when they pop up on the market or when they fulfill your needs. So the grounding information will be available through the NeMo registry. There is a registry here. So here you can find all information, including the semantic model, which you need to link to the service during build or as well during runtime. Okay, that was a short introduction. As said, technical details will follow in future webinars. So the summary and conclusion is, with NeMo, we will provide a distributed, not a centralized service IT environment. So it's easy for all partners to join and to provide the services and contract it based on this distributed ledger technology, blockchain. It's an IT environment for easy search and use of third-party services. In addition, we will provide, this is also shown in a minute, a VPN-based tool suite that provides you the visibility to specify value-added e-mobility services by combining, let's say, single low-level services to a higher-level service. And of course, we also provide an IT deployment and delivery mechanism that's really easy to use and to take part into this NeMo open market. Next session, I also will show you the common information model so that all services will comply to this information model. We are also planning to provide translators where services which are not yet complying to our SIM model can easily provide mechanisms to translate their proprietary interface into the SIM model. So once that is done, it's really easy for applications to use it. So that all leads to increased innovation and towards to a digital single marketplace for e-mobility services around Europe. Yeah, if you have questions, that's at the end of the webinar. And now I would hand over to Johannes for his part with the details on service creation.
Okay, thank you very much, Thomas. If you have questions, as I reminded, just write them in the chat box at the bottom, please, and then we'll read them out when there is time. So I'll pass over to Johannes now. Johannes Fendrich is a scientific researcher from the Technical University of Berlin with a diploma in computer science from Karlsruhe Institute of Technology. He is involved in several research projects in the context of electromobility with a specific focus on adaptive systems and semantic service technologies. He is currently working on solutions for autonomous service selection and composition, and also later this month he will complete his PhD. Johannes, I'll hand over to you. I need to unmute you. I can see your screen, and please go ahead. I can hear you.
Okay, perfect. So next we will look at the development part. So the main question answered in this tutorial is, how do I provide a service into the NEMO network, and how do I use one if I want to create a value-added service? So we start out with the short motivation. Why do we need such tools? Then we have an overview of the development process and the service description. And at the end, we look at how such a service is executed for the developer to test the services he has provided. To start out, such a network as the NEMO network is, of course, distributed, and it has a huge amount of services in a wide range of domains, and has a multitude of service providers. With this, there comes a multitude of challenges. So this starts with the interoperability, so finding services, calling them, and getting the right interfaces. For service developers, this means describing new interfaces each time a new service appears. To get over this hurdle, one proposition is to use tools from the semantic web, like a semantic description of services. A semantic description of services provides a profile and a high-level interface to a service, which lets you search for services in a fuzzy way. So having descriptions which do not totally fit something you're looking for, but will still return a service. So that is for that, we need to describe the service semantically, like what input does it need, what output does it give, which preconditions need to be fulfilled so that the service can be called. The difficulty for that now is that describing such a semantic service description is a lot of work. It normally is done in something like a vast amount of XML, which is not really helpful for the developer. So one part of the goals of NEMO is to facilitate this service development and to get closer to an automatic finding and invocation of services. We provide solutions for an easy integration into the NEMO Hyperledger network of a service, of a new service, and provide a functionality to describe service semantically. Next, an overview on how the service, how we see the service development process. In the service development process, we have different actors. One of them is the service provider in the top right. He provides the service, describes the service semantically so that others can find it, and executes the service in the NEMO network. Then there are service developers using existing services to create new value-added services. In addition to combining services into a new process or a new flow of services, there is a third party, which is the ontology engineer, which describes these services and their entities in an ontology, in an abstract manner, so that the execution can have a service description or an entity description, which is computer readable. So starting from this flow, we are going now into how such a process can be defined and how such a service description can be created. To look at this, we do this on an concrete use case. Our use case is a semi-public charging environment where we have 3 charging stations, 4 parking spaces, a gate guarding the parking spaces so that not everybody can park there, and of course a vehicle which we can book and then charge somewhere. So the question answered next is, how do we create a complex mobility service to such an example? So what we'll do next is to look at our tool, and this will be done in a live demo. So first I will explain the interface of the tool a bit before we go into the live demo. This is a Eclipse-based tool which has different parts. One part is the BPMN editor. It describes processes in the BPMN notation, as can be seen here, which is a quite powerful language to describe business processes. Each activity, each white box, can be seen as a user interaction or a service call, which then in its totality creates our new service. In addition to that, on the bottom we have a semantic service description tool or semantic service management tool, which allows us to create service descriptions and to upload them into the NEMO network, and additionally to search for new services providing a service description. I will switch over to the tool now. As you can see, now can you see the tools? I hope so. Okay.
I can see, yes. Yeah.
Perfect, thanks. So we have an example process here. So let's imagine we want to provide a service for an end user to charge a car. What we do in the services is we get the location of the user, normally provided by GPS. We create out of these states, we create a location. We then search for charging stations surrounding this location. We let the user select one of those charging stations he wants to book. Then he needs to select a time from when to when he wants to book the charging station. We create a date for that. We create the booking. If the booking is possible, we wait for the user to get to the gate and then start the charging. Or if the booking is not available, we need to select another time and again then create the booking. Of course, this is just an example process we are using here to demonstrate our tools. At the bottom, we can see our service description tool. This is an interface to create OLS files. So in our example, let me just start. Now, in our example, we want to create a service which gets the state of a charge of a vehicle. So we start out by giving the service a name, something like get state of charge for vehicle. We add a description for humans to read, and now we start specifying the semantic interface. So as you can see, we have 4 boxes here, one for input, one for output, one for precondition, and one for effect, to describe the interface of the service. Imagine we want to specify an interface, an input for this interface. As an input, we could imagine that we want to get a car for which we want to read the state of charge. So this will be my car. We have loaded our common information model into our tools, which of course can be extended in the future. And in this common information model, in this ontology of all the objects we are supposed to handle in the NEMO network, we can now search for entities we have already specified. For example, a car. So we find a car, we see all its properties, like a color and where its home is, and so on, and can add this as an input. For an output, we want to add whether the state of charge. So let's say current SOC, and this would be a double between 1 and 0, let's say % of the battery state of charge. So it's a double. Now, as a precondition, since this cannot be just any car, we want to formulate a precondition damn it. I have to redo this. Okay, the current state of charge. We want to create a precondition which identifies our car as an electric car. So we call this one a precondition. It's just an identifier. And we add a precondition like an electric car of my entity, my car. So you can see that you have syntax highlighting here and syntax checking. This means that we demand from the input we have specified up here that this car we give in there is an electric car, because there is no state of charge of old fossil fuel cars. So having described this service, we now want to upload this into the NEMO service registry, which we do by deploying it into the NEMO network. Now this will be done now. Has been uploaded successfully. If I get a browser, let's see here. We see our get state of charge of a vehicle is here. We have a semantic description with all the XML created. We have our precondition as we have specified my car needs to be an electronic car. Okay, so that was the first part of the tutorial on how to get service described and published into the NEMO network. Now we get to the second part on how to use such a service in a complex composition of service. Such a process we have introduced up here. So to start out, we need to find the service we want to use. Imagine in the workflow I have introduced shortly before, we want to add an additional service to open the gate before getting to the charging station. So what we want to do is we want to find a charging a service with a which opens the gate, blocking our parking lot. So what we do is we are looking for, let me look up this again, for a service called open gate. We start the semantic search. Of course, we can specify if we know more precisely which kind of service we want, which input we want, which output we want, and so on. We can identify the different parameters of the service. For us now, we cannot find our service we have specified before, and of course, where is our service? I have to go through it. Oh, I'm sorry. Seems that we have lost our service. So normally the service we want to find appears down here. Somehow it seems to be got de-employed, and we can find like this one. We can import the service into our tool by clicking onto this box. So now the service has been imported into our local process, and we can add an activity which uses this service. For example, here we add a new activity called open gate, and for this to specify what this activity is, we go into the property view and tell it that activity can be different types. So for us, it will be a service, but of course it can be a sending or receiving of a message. It can be a user activity, like the selection of a charging station up here, or it can be any number of other different activity types.
Mm-hmm. Hi, Johannes, sorry to interrupt. There was one question which I saw as well. We're all getting little vertical bars in the text areas that you're showing. Is that normal? Is that just your interface?
The vertical bars. You don't see what I'm selecting?
I can see what you're selecting in the drop-down menu, but in the fields above where it says core and appearance, there's a lot of like interference. You can just about read what you've written.
Okay.
Yeah, move a little bit the window. Maybe it makes a refresh.
Yeah.
Better like this?
Not really.
I'm sorry.
No,
I don't know how to increase the resolution here.
Control plus.
I don't. It's a Docker container, so I don't know.
Okay.
I'm sorry.
Okay. We can see when you write something in, you say what it is. We can just about see it, but it's just a bit messed up the screen. But the bits below are fine. Yeah. Just want to check.
Of course. So I will say what I'm writing. So now we have imported all the services we needed, and we select which service should be called. In this case, it's a open gate service, so we want to open a gate. What we need to do now manually is still to assign the parameters. So now we have a service with this interface. The tool knows in the background what's the service, what's the semantic description of the service, but we need to assign parameters. So to open the gate, we have an RFID chip, so some kind of user token, which authenticates the user. Then the gate authenticates the user, opens the gate if the user is one which is allowed or which has a booking to a charging station, and then it opens the gate. So to assign the parameters, we see that this semantic description has been analyzed. There are two parameters, one input parameter, which is the user ID, and one output parameter, which is mapped to the variable, the process variable opened, which stores a Boolean stating if the gate has been opened or not. Then we integrate this new activity into our process. So we start out by which activity is before it and which comes next, because it's the last step of our process. After waiting for the user to arrive at the charging station, we then open the gate and then finish the process. Okay, now we have this updated version of this process, and we want to redeploy it into the NEMO network and test its functionality. As a service developer, I'm done right now, so I want to do the testing and see if all the service calls we have added in here and the DOI works as specified. So in the background, there is an interpreter, which is a BPMN interpreter, which then can be used to execute a service and interpret the BPMN specified and see if all the service call functions. It provides a small UI which allows us to track the process of the process and the state of the process, and provide inputs if they are not yet implemented within real UI. So we now deploy, there's nothing deployed, we now deploy this process. We have the service user, which is the only role we have here. So it has been deployed successfully. Now we look at the interpreter UI. In the interpreter UI, we have now deployed our one service, and we can invoke the service to execute whatever we need. So the first part is now get an identification of the user. So that's the input of the overall process. So let's say our user identification is 1234. This is used in the background, as you can see, to get the next, to invoke the next service, which asks of us a location. So because we have not connected a real GPS device yet, we will provide those manually. So let's say we are somewhere around Berlin, because our charging stations are stationed here, 1, 2, and within a distance of about 1 kilometer. So now the next service is called, we create a location, we get the charging stations. Now we are jumping to the activity of selecting a charging station, which again is a user interaction. So we have found some charging stations. Come on, yeah, there it is. And have to select one we want to book for our user. Normally this would be, of course, displayed in some kind of map or something. But for the developer to see that the service calls work and how the parameters should be selected, this is a simple UI. So now we are asked to create a booking. So the booking is specified in this service as a offset and a duration. So let's say we want to book the charging station in 30 minutes for 2 hours to do some shopping. After that, we are waiting for the user to get to the gate. And once the user has reached the gate, he can click OK on his cell phone, and then the service for the opening of the gate is called, which then again asks the user for its identification. We have already added an identification of the user, which is our 1, 2, 3, 4. And with that, the gate has been opened, as we can see by the assignment of the variable to true, that the gate has been opened. So even this service we have added right now at the end has been called and has been called successfully. Okay, I know that was a lot, and it was probably too fast to follow, but you can do this tutorial on your own. I want to summarize what we did. So we did a semantic service description of a service we wanted to deploy into the NEMO network. For this, we have provided a tool which is available in a Docker image, which you can download and start at any of your computers. There is OVLS support, so a semantic description using OL as an ontology language and Swirl as a rule language. And we can deploy services into the NEMO distributed registry by using this tool. Then the second part, we have searched for a service and used one of the services in one example process, so that we can invoke such a service at runtime. And last, we have seen the service process development tool, which allows us to specify BPMN and service integration into a process, and with that create value-added services. So, and finally, we had our development execution environment, which allows us to execute a process diagram directly. So have our service tested, our value-added service tested, and deploy such processes into the NEMO network. So in conclusion, we have shown a BPMN specification process for value-added services and support for semantic enhancement of service functionalities, and how to search and deploy new features or new services into the NEMO network. So thank you. Are there any questions?
Thank you very much, Thomas. I will put questions to Thomas. Sorry, Johannes, or to Thomas before him. Yep. Johannes was just now. If anyone wishes to write one. In the meantime, we've got about 13 minutes left. I will take back the screen and I will just show you just some final information about the project while you're thinking if you wish to ask any kind of question. So, second. One second. Try to make myself center. Okay, here's just a little bit of extra information about the project. If you wish to follow us more, you'd be very, very welcome. You can join our stakeholder forum at the address there. Go to NEMO eMobility EU, and then it's the top right option, forum. And then we can keep you up to date on all future events, news, tutorials, webinars. Beginning of next year, we'll be having a hackathon when the network is more operational. And this will contribute to the validation of the tools and service creation environment in the Hypernetwork. And also, we had our first stakeholder forum conference last October in Stuttgart, and there will be another one sometime next autumn. We haven't decided where and when yet, but it will be September or October maybe. And you'll be very welcome to come to that. If you missed our Stuttgart event, all the information, report and the presentations are already on our website. And in the next few months, we'll be going to these events, to the Transport Research Arena in Vienna in April. There will be a demonstration at the ACME Energy Conference in Karlsruhe, Germany in June. There will be a workshop organised by NEMO and by another project, Electrific, with which we are cooperating. And then there's the Intelligent Transport Systems World Congress in Copenhagen in September, where we'll have a session. And below are our website, Twitter and LinkedIn, where you can follow the latest news. And when we have reports, we will upload them on the website. That will probably not be until end of May or June when we have the first batch of reports approved by the European Commission, but we'll keep you up to date on those media. Questions? I don't see any more questions from anybody at the moment. We will share an audio of this presentation at the end. I'm afraid the audio, we only started it when Thomas Waltz started the introduction, so you'll miss the beginning, but all the important part is in there, and the general information on the project you will find on the website. We'll also share the slides with you that you've just seen. Among the presenters, Thomas, Johannes, or Christina, do any of you wish to make any additional comment or question to the audience in the last few minutes?
Thomas, if anybody has questions regarding the service creation or the Hypernetwork, how you can bring in services and contract them, welcome to ask the questions. And also, if you think of any later, then you will see our contact details on the at the end of the presentations that we will send you, so you can contact us by email individually. And if you have good ideas for good services around e-mobility, that's the place to be. Yep. Okay, so I don't see any further questions or any comments.
So I'll propose to close this webinar. I'd like to thank very much Christina Anagnostopoulou from ICCS, Thomas Waltz from IBM, and Johannes Fendricht from Technical University of Berlin for your presentations. And we hope to see you at one of our future events, for example, TRA, if you're in Vienna in April. And we will we'll stay in contact. Thank you for joining, and have a good afternoon. Bye bye.